Right, welcome to Unit 2. Unit 2 on dynamics, or really forces. First thing you'll notice here is that the combination of kinematics and dynamics makes up the field we call mechanics. So this unit is all on dynamics, in other words, forces. They're often misunderstood, so we'll go over this nice and slow so you get some of the basic concepts of forces. Now, to start with, we talked about one of the most one concept which people believe, scientists believe, and it seems very intuitive, and that is this one right here, that the natural state of an object is to be at rest. And they believe that a constant force results in constant velocity. Well, we know that that's not true. Thanks to the work of Galileo, who said to himself, well, I want to do all my work in a world where there's no friction, because friction makes everything complicated. And he did some brilliant reasoning, and here's a simple one that but very powerful, and that is if you've got an object here, this ball rolling down the slope, it's going to accelerate. Why? Because gravity's pulling down on it. In the second diagram, you've got a ball rolling up the slope, it's going to slow down because gravity is pulling down on it. But if it's going on a level surface, then it has no reason to accelerate, so it should just go at a constant velocity forever, which is totally true. If there are no other external forces acting on it, the ball will go at a constant velocity. Now, of course, in the real world, there's friction. There's friction right here, and so the ball will eventually slow down. But there is no friction, then the natural state of this object is to just keep moving at a constant velocity. And you can extend that idea. If I take a ramp like that and I send this ball down it, this ball is going to accelerate. When it gets to this point here, it's going to have a specific velocity, and then what's it going to do? It's just going to want to keep going at a specific velocity. It has no reason to accelerate anymore because gravity is still pulling it down, but now it's moving in a direction that's perpendicular, and of course the ground here is pushing up on it. So it has no reason to accelerate anymore. So what will it do? It'll just keep doing what it's doing, moving at a constant velocity. Okay, and that is you can look over these experiments. Again, very logical. You set a ball going down the slope, it's going to go up to the exact same height. If you reduce the angle here, it's still going to go up to the same height. And then if you don't have another side right here, what's it going to do? It's just going to keep going at a constant velocity. So this is a very important concept, that the natural state of objects is to be either stationary or moving at a constant velocity. And then the last example we have in lesson 20 is, again, just something for you to consider. If you have a 5-kilogram object on a rough surface, you need a lot of force to push it. If it's a smooth surface, you need not as much force. If it's a really smooth surface covered in oil, you hardly have to push it at all. Or think of a hockey puck on an ice rink. As soon as you set that thing in motion, it goes a long way before friction slows it down. If there's no friction, once you push it, once you get it started, it's just going to go on forever because there's nothing to make it stop moving. So just mull over those concepts. That's lesson 20 in a nutshell. And the important things to realize, to understand from this lesson, are that the natural state of objects is to be moving at a constant velocity or stationary. In other words, the natural state of objects is to do what they're already doing, but not to accelerate. All right, we'll see you at lesson 22. Oh, lesson 21 first, actually.